Hello and welcome, my dear students and viewers, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you to part 2 of our session. This is useful video for grade 10 elite students, and this is part 2 of chapter 1, lesson 3, matrices. So this lesson is given in your math book on page 21, and if you have not seen my previous video, which was part 1, an introduction to matrices, I will provide the link in the description box, and you can click on the top right corner of this video to watch that first. After you watch part 1, part 2 will be easy for you. So today's learning objective, what you are going to be learning. You learn, now that you know what is a matrix, how to organize a given data in the form of a matrix, and then you'll also get to know about equal matrices and how do you identify two equal matrices, and further in the session we'll also see how to solve problems on equal matrices. So let's dive into the video. I would want you to check your understanding of the concept of equality of matrices in this video towards the end, trying out the questions that we are going to be discussing. So let's get into the video now. We move to a learning objective of organizing the data in a matrix. I want you to recall from previous session, that was part 1 of the video. I want you to test yourself and see if you've understood part 1 of the session. So let's do some questions to check your understanding. State the dimensions of the matrix A below. So this matrix A, denoted by capital A, that was a rectangular arrangement of numbers into rows and columns, is given to you. A, B, C, D, there are 4 options. It's a multiple choice question. You have to choose the correct answer. So recall, dimension means order of the matrix. So you'll have to count the number of rows followed by the number of columns. I hope you remember, rows are horizontal, columns are vertical. So R1, R2, R3. There are 3 rows. This is the first one, second one, third one. Let's change color and mark the columns. So how many columns there are? C1, C2, C3, C4. So there are 4 columns. This is the first one, second one, third one, and fourth one. So if you look at number of rows, it is 3, number of columns, it is 4. And how do we write the order of dimensions? First you write the row. How many rows are there? Multiply with number of columns. So it will be 3 cross 4. So your answer is C. Okay, let's do one more. What is the entry or the element B23? So when I say B23, this is capital matrix B given to you. Again, it's a rectangular arrangement. Let's see rows and column. 1, 2, 3 rows, 1, 2, 3, 4 columns. So this is a 3 cross 4 matrix, just for your information. And out of these matrix, you have to identify B23. So we can say this is the entry, or another name is element. At which position? The position is denoted by 2 followed by 3. So means first is row. So row 2. Second entry denotes column. So column 3. So which is the element in second row and third column? Let's mark it. So R1, R2, R3, C1, C2, C3, C4. So we need to be at second row. So this is row 1, row 2, this one, and third column 1, 2, 3. So this is the element. So I hope you're able to understand that B23, which was the element at the second row, and column 3 is the number 4. So B is your answer. So that was from your previous class, part 1. Let's see now what we are going to learn in this video. Check your answer for the dimensions of each matrix. Question 3 has matrix which has 2 rows, 3 columns. Question 4 is a column matrix. I hope you can see here that it just has one column, not more than one, and 3 rows. So that's why 3 cross 1. Next is 4 cross 3. Next is 3 cross 3. I hope you can recall and identify that this is a square matrix because its number of rows and columns are same. Then you have 2 cross 5, 2 rows, 5 columns, and finally 3 cross 2. Now, I want you to think of examples of each type of matrices. Again, this is all coming from part 1, just to check your understanding. So I've provided here sample answers for row, column, and square matrix, but definitely this is not the only answer. You can have more than one answer for this question. So just provide any example that suits you. So for the row, column, and square matrix, you may change the numbers inside, you may change the entries and example. As long as you put just numbers, positive, negative, zero, it is a correct answer. Okay, so now we are on today's session. So what do you have here? So this is a table given to you and you need to organize the information which is given in this table using a matrix. Okay, so first let's look what is there in the table. Let's observe it a little bit. So this table gives you the information about roller coaster. So there are three of them, A, B, and C. So that's your column 1, column 2, column 3, the vertical ones. Okay. Then for all these roller coasters, you are given the speed, first row, height in feet, second row, length in feet, third row. So we can say R1, R2, R3, that's the horizontal one. Now, because we are just organizing the numbers or the entries, elements in the matrix notation, so we are just going to pick up from here. So you know a matrix is denoted by these square brackets entry. So if I just name this matrix with a capital letter R denoting the roller coaster, that's the notation I use. Then the capital matrix R, you may use any other alphabet to denote, it's perfectly fine. Then I write the first column entry, so 55, below that 90, below that 2300. So that's my C1. So now C1, C2, C3, I'm not going to write again because I've already written that for you to identify on the top. So we just write the elements inside. Okay, first row, second column, that's 50. First row, third column, that's 70. And then just below them, I write the remaining numbers. So this is how simple example of organization of data information table from table you got it into the matrix. So this is how you do the organization. Let's take another example. Again, our learning objective is same. We want to organize data in the form of a matrix. Now, sometimes in your exam, you may be given a word problem in organization. So what is given here? Let's understand. Sharjah High School football team uses 5 forwards throughout its season. So 1, 2, 3, 4, 5. These are the 5 options of the 5 forwards. The first person is Jamal, followed by Ibrahim, Kareem, Saad, and Ahmad. Now, for each of these players, the 5 forwards that you have, there are given some data, some information that you want to compare for each player and then organize the data in the form of a matrix. So for Jamal, there are 11 games, 72 passes, 4390 meters, 6 goals and 8 fouls. Now, if you observe, I'm just going to change color and highlight that for you. Some entries are seen for all these 5 people. That means games, games, games. All of you can see the numbers are differing. Like Jamal has played 11 games, Ibrahim has played 9 games, Kareem has played 11, Saad also 11, and Ahmed 10. So one entry would be games, then passes. Again, that's a common next criteria, and again these numbers are changing. Then you have the meters followed by goals and fouls. So when we do the organization of the data in the matrix, a condition is given. What is the condition? You have to organize the matrix from the greatest to the least attempts. So let's see what is the greatest attempt and then we'll come to what is the least attempt. Okay, so that means from greatest to least means descending order. Okay, we are going to do that in descending order. So when I say descending order, I mean to say greatest to least. Okay, so let's look at the information. So total games, that's one, then passes, that's another, then the height in meters, goals and fouls. So if you look at the passes, let's see how many games Jamal has played. 72, 143, 164. Similarly for Saad and Ahmed, this much. So which is the maximum? So we look here that Kareem has the maximum passes, 164. Then next is Ahmed 151. Then next is Ibrahim 143. Next is Saad 84. Next is Jamal 72. So Jamal is the least passes and Kareem is the maximum passes. So because we have to do from greatest to least, the order would be Kareem followed by Ahmad, Ibrahim, Saad and Jamal. So I hope this player organization is clear to you. And then on the top of the columns, we have the headings for games, passes, meters, goals and fouls. So accordingly for each player, like we begin with Kareem, 11 games, so 11 here entry, passes 164, meters 8850, goals 5 and fouls 50. Now when you are putting the second entry for Ahmad, row 2, you have to be careful that you are putting the same entry below the other. What do I mean by that? So if you are putting games, you put 10 below 11. If you are putting passes, you put 151 below 164. Meters 9660 below 8850, 6 below 5 and 11 below 15. So this is how you organize the matrix. Now if I may ask you, next question, what are the dimensions or what is the order? What you do? Count 1, 2, 3, 4, 5. So how many rows? 5 rows. 1, 2, 3, 4, 5. How many columns? 5 columns. So think about what should be the name of this matrix. So dimensions are 5 cross 5 and definitely because rows and columns are same, it is a square matrix. Okay. Now, second thing is, last thing asked in the question, A34. So if you know, name this matrix with a capital A, then the element at row 3, column 4 would be A32. So 1, 2, 3, 1, 2, 3, 4. So 7 is the value of A34. If you've understood this question, I want you to think about, take few seconds for A4, 5. What is going to be this element? I'll give you answer in few seconds. Okay, so have you got the same answer? 1, 2, 3, 4, fourth row, 1, 2, 3, 4, 5, fourth column, fifth column. So this is 7 again. So that's how I hope you've understood a word problem on organization data in a matrix works. Now we move to the second learning objective of today's class, which is identifying, defining equal matrices. Now matrices A and B, if two matrices are given, how do you identify whether they are equal or not? So there are going to be two conditions that you check. Number one condition, they have same order. Same order means they have same number of rows and same number of columns, right? That's how the order will be equal. And number two, they have same element at same positions. What does that mean? So if you have two matrices given to you and you have an element, like for example, let's look at this one, A and B. Let's check are they equal or not. So the first element, first row, first column is 3. First row, first column is 3. Next one is also same at the correct position. Next one, first row, third column is same. And if you observe, all other elements are also same. So we can very well say that A and B matrices, A equal to B, because they satisfy both the conditions. Let's see another one, matrix C and D. So matrix C has how many rows? 3 rows. How many columns? 2 columns. However, this is opposite, 2 rows, 3 columns. So their order is not same, it's different. So if order is not same, this condition is not true and therefore they cannot be equal. So C is not equal to D. Now, second thing which will definitely come in your exam is to use the equality of matrices to solve for variables. So sometimes you're already given, you don't need to check that the matrices are equal and that you will use to find the value of the unknown variables. So let's look at these two matrices. Now this matrix is equal to this matrix. It's already given, they are equal. So when such a thing is going to happen, these two conditions hold true. And if you see, they both are square matrices of order 2 cross 2. So first condition is very well true. Let's see the second condition. They have same element at same positions. So that means x plus 3 should be equal to 6. Y should be minus 1. So you got one variable, and z minus 3 should be equal to 4. So these three equations you will get as equal. And why they are equal? Because the corresponding elements have equal values. So this condition helps you to solve for variables. So if x plus 3 is 6, we subtract 3 from both sides and you get value of x. Add 3 to both sides, you get the value of z. So your x is 3, y is negative 1, and z is 7. So you solve for all the three variables using the concept of equality of matrices. So let's now try one question together and I want you to check your answer. So these two matrices are equal. As you can see, they have same order, both are square matrices, and here the variables are a, b, c that you need to find. Now because they are equal, this first element at a11 position, first row first column, is equal to this. So a plus 3 equal to 6. How do we solve for a? Just subtract 3. So you get, this cancels, a is equal to 6 minus 3, so a equal to 3. One variable is done. Let's go to the next one. B is equal to negative 1, so this was quite easy. You need not do any solving. Just compare and you get your answer. Let's come to C. So for the third part, you can compare C minus 3, that's equal to 4. Element at the second row, first column, they are equal. So you add 3. And what you get after cancellation is the value of 3. So 4 plus 3, C is 7. So that's how you get all the three variables A, B, and C, the unknown variables, using concept of equal matrices. So my next video coming up on the channel is part 3 of chapter 1 lesson 3 matrices, useful for grade 10 elite students. So make sure you subscribe to my channel and hit that bell icon to receive notifications of all my upcoming videos. That brings us to the end of part 2 of matrices. Thank you for watching. And if you found the video useful, hit the like button and put in your comments and queries or questions in the comment section. Until then, this is Ms. Ruchika signing off from this session. See you in my next video. Bye-bye.